Okay, I'm back, and now we're continuing our review of the gas giants and Pluto. And so now we want to talk about the moons of some of these objects. So you got to know about Io. You should be able to describe what would it be like to stand on the surface of Io, and you should be able to tell me what causes the heat on Io. Okay, then Europa, you should be able to tell me why would there be liquid oceans underneath the solid crust of ice on Europa, and then why is that important? Okay, then you've got the moon Titan. So Titan is a moon of Saturn. Okay, and then be able to tell me about its liquid oceans of methane and then its hydrological cycle. So how this methane can turn into a gas and then turn into clouds and then rain methane back on to the surface of this moon, and then explain why is this important. All right, do not worry about Triton. So that's not going to be on the exam. Okay, ring systems. So for Saturn, you need to be able to tell me what are the rings composed of, and then how do those little pieces of ice behave according to Kepler's laws. Let's not worry about the Gap and the Shepherd moons, but I would like for you to be able to tell me what keeps ice in the rings, because that ice its orbit should deteriorate, and then it should fall into Saturn, which means that those rings should only last for maybe a few million years. So there's a mechanism that keeps fresh ice in the ring system. What is that mechanism? Asteroids. I just want you to be able to tell me that asteroids are composed of rock and metal. Okay, that's it. You should also know that asteroids are very, very big, and that asteroids can do a lot of damage if they were to hit the Earth. You should know what killed the dinosaurs. Okay? So now let's talk about comets. You should have an idea for how big comets can be. You should know that comets are composed of ice, 99% ice, and about 2% dust. And then that 2% dust is going to be the same materials that are in asteroids. Okay, you should be able to tell me what kind of ice is in a comet. Explain why a comet develops a tail. Okay, then be able to tell me where is the asteroid belt located, where is the Kuiper belt located, and what's in it, and then where's the Oort cloud located, and what's in it. Okay, factors that influence the evolution of the outer planets. So you've got what was it initially made of. So that's going to determine what it eventually becomes. How cold was it? So how far away from the sun was it? Okay, then the initial mass determines the composition. So like for example, Pluto was very small. So it didn't have much gravity, so it couldn't grab onto much. On the other hand, Jupiter was larger, so it got more gravity, which meant it grabbed onto gas, and so that's why it became a gas giant. Then also, smaller objects cool off faster than larger ones. And then the idea that a large planet can exert tidal forces on its moons. So what's the history of the outer planets? So initially they all had a rocky core. They next started to attract ice onto them, but Jupiter and Saturn grew larger than what Pluto could because they had more ice to work with. And then they got so large that they were able to also grab onto hydrogen and helium. But Uranus and Neptune, they had less hydrogen and helium to work with, but more ice. So that's why they ended up looking different. Then chemical differences in the gases arose because of differences in temperature and pressure. So that would account for the different gas clouds in Jupiter and Saturn, Uranus and Neptune. They're different chemicals. And the gas and ice giants collected large numbers of moons because they've got more gravity. Pluto and the other objects further out than Neptune are basically just debris from the formation of the solar system. Okay, so in our next and last series of videos, we're going to talk about how a planet such as Jupiter can migrate.